Alright, hello guys, welcome to another video of our LeetCode 60 plus days solving challenge where we solve LeetCode questions from easy to hard. So the last time we solved the hard question, the time before that we solved a medium question and so on. So today we are tackling an easy one apparently, and it states and reads remove duplicates from sorted arrays. Question is problem 26, right? And given an integer array norms sorted in non-decreasing order, remove the duplicate in place such that each unique element appears only once. The relative order of the elements should be kept the same. You understand? Consider the number of unique elements in norms to be k. Right? After removing duplicates, return the number of unique elements k. The first k elements of norms should contain the unique numbers in sorted order. The remaining element beyond index k minus 1 can be ignored. So, custom judge. The judge will test your solution with the following code. Int norms equals to that as the input array, the expected answer with correct length, int k equals to remove duplicates norms, calls your implementation, accept k expected norms dot length, accept norms I equals to expected norms I. If all assertion pass, then your solution will be accepted. So for example, they give you example here 1 1 2, and output should be 2, and norms equals to 1 2 and an empty array. Explanation: your function should return k2 with the first two elements of norms being 1 and 2 respectively. It does not matter what you leave beyond the return k. Hence, they are underscored. To have example number 2, norms 0 0 1 1 2 2 3 3, and yeah, so it basically 1 2 3 4, and then okay. Right. And then you have the constraints here, norms.length, which is the output array should be between 1 and 3 to the 10 to 3 times 10 to the 4, and norms I, each element should be between negative 100 and 100. Norms is sorted in non-decreasing order. Okay, so there is something I want to try. Okay, after solving LeetCode for so long, there was a particular approach which has been interesting to me. So, which is basically, and this is where I wanted to get to, and when in this challenge is like extracting the algorithm to solve a particular problem without the implementation, like just textual. So we're going to use comments and writing the algorithm before we implement. I hope that makes sense, and we're going to try this now. So from what I understand, right, so when you're giving an input as such, right, we need to first of all need to sort this array in decreasing order, although it's already in decreasing order, but it's in non-decreasing order. Doesn't mean that it's necessarily in ascending order, which means that they can be repeated values, right? That's why they use non-decreasing. So we need to return it in decreasing order, in the sense that they are unique. So basically, remove duplicates, like return unique elements. You can you can allow the elements, you can remove the elements, and that's the idea of it. So obviously, I want to iterate the array, right, till the last unique number. But how do we want to iterate it? If we iterate like this, from this to this end, then what will happen is we need to go through all of them. Even though when we get to the last number, and if it continues to like 100, we need to continually iterate through, which is not really efficient, right? It's not really that efficient. So what we want to do, once you use some kind of a two pointer from the lower and the top, in such a way that although I have this start here, right, I also want to mark this, and I will iterate here to this end, but I want to mark this end because I want to go, when I iterate, I want to take the first value and then I keep it in another array, add it in another array, right? And then um, ask if this value already exists in the other array. If it does, we skip it. If it does not, we add it, right? So in sense, iterate through the array, right? Use save the end, the last digit, and you see why I did this of the array, okay, in a temp. But we don't need to save the last digit of the array in a temp since we already have length. So first of all, compute the length. So we'll do compute the length of the array, right? And then when we iterate through the array, what we want to do in each iteration is that we want to check if the current element in the input array is found in the output array, right? So we need to compute the length of the array, initialize output array, right? And then so let's make it a bit of space there, so that it looks a little bit cleaner. And then we want to check if the current element in the input array, which is this, is found in the output array, which we have initialized there. If true, or let us say if false, right, add current element in output array, right? However, else skip current element. And now this there is something I also want to check, right? So while I'm checking if the current element is in the input array, if the current element in the input array is found in the output array. That's one check. I also want to check if the current element is same as the last element. Now this will save us some time, right? So for example, if we have inputs and I want to put, if we have inputs such as that, let's say this, right? And this is the idea, and they will have like a repeating for here, just repeating, right? Now if we don't do this check and we get to the first four, what will happen is we'll just keep iterating till the end here, right? And I don't want that, right? Although we skip it, you'll be skipping, but it will just continue the iteration. So they can literally just put one, right, and then a repeated number of values here, and then your code is just going to run for a longer period of time, which is not so much efficient, right? Now there's other values. Of course we can have multiple ones here, right, but they are not, as long as they are not the last, you really, there is no way to tell them apart. Okay, there is uh, there's really no way. However you want to do it, I think it's still going to require you to iterate. You can put a while loop and then check the while loop if the next element is equals to the next element, and just while and skip, or you can still leave it like that and it's going to check, right? um or we can do while current element, or even within, after doing that, even here, or even after. So we have this skip else. So if current is found in the element and current is the same, sorry, it's not the same, it's not same as the last element, we want to check if false. So we want to check if it's false. uh, right. So if that is true, sorry, if true, if the current element in the input array is found in the output array, so no, it's not found. So if true, sorry, it's not found in the output array, right? And so we want to check if that argument is true, we want to add it to the current to the element, and then we can just do like a while loop here, right? So we want to iterate rather than just doing the iteration here. So we can just iterate and check. So iterate the until iterate while the, or you say increment, or let's just say move to the next element while the next element is same as the current element, right? So we want to move to the next element as long as this next element is same as the next is as this element, right? So if we say is I plus 1, is I plus 1 same as I, we want to increment um, I to I plus 1, right? So we'll increment I plus 1 here. So we have like increment. So before we move to the next element, then we'll compute the move. We'll move to the next element, will just be like a simple increment, and then we'll just like iterate and move to the next element while the next element is same as the current element, right? And then while that is true, it's just going to move to the next element until it finds that it's not the same, right? And then it's going to skip it. Else it's going to skip it and then in this else we want to, so with the next element, this is all indented within the if, and then we want to do this, move to the next element. So yeah, and then we want to be able to return. So when we have done that, the while is going to close. We want to return. We want to return this is return an int. We want to return the, how do you call it? Where is it? Technically, this does not stop it. It just allows it to skip, and this iterates. Check if this fails. Oh yeah, so we want to break out here. So when if this fails, right? Check if the current element is found in. Let me see. Check if the current element in the input array is not in the output array. Right. The input is not in the output array. If it's in the output array, I don't know if we're going to use the or here. We can use the or. Check if the current element is in the input array, right, is not in the output array. That works. So we check if it's not in the output array to be able to do something like this. Now, if it is in the output array, we want to do, if it is in the output array, we'll skip and we'll do the else. So the else should, yeah. So if it's the output array, we'll skip and just move to the next. If they are also the same, but if it is in the output array but not, if it is not in the output array, then you will enter. Or if it is not the same, but if it is the same and it's also in the output array, so if we get to the last one, so we have that 4, that repeating 4 here, we get 4, then it's going to ask, is it in the output array the first time? No. But is it the same as the last? Yes. So it's still going to enter. But when we get to the second one, is it in the output array? Yes. Is it the same as the last? Yes. So it is not going to enter, it's just going to skip. And so yeah, we want to break here. So we want to break loop, right? And that basically marks the end of it. And then we want to return the length of output array, and then so we want to basically assign norms to out. So assign norms, because I'm saying here that they're checking, they will check norms, right? What I'm saying is that they will check norms. So we will simply just assign norms assign norms to output array, right? And then maybe just return length of norms. Yeah, length of norms array. Yeah. So that is the algorithm that we've come up with. We'll see if this works. But yeah, that's what we've come up with. Okay. And let's try to code according to how we addressed it. So compute the length of the array. So we are going to have int length. Let's put length equals to norms dot length. Right. I think that is it. Is it like that? No, that should be the string. I think this should be correct, right? But anyway, we'll check. We'll check it. I think for string for string that we're going to put the bracket there, which is a function of the string, but array is just a length. Yeah. Initialize output array, so we're going to have int, right, equals to, yeah, basically new int. I can just put like int equals to, is it like this or like this? Oh, sorry, which is uh, anyway, we'll come back to it. I kind of forgotten this one. Is it like new int? Does that make sense? Int output doesn't make sense. Anyway, we'll see. We'll find out. Find out eventually. It's norms iterate the array till the last unique number, and we are going to go for int I equals to 0, I less than length, and we'll have I plus plus. Right? So that's basically what we want to do. Since we're returning here, I think this is where it closes. Yes. And then we want to check if the current element, so we want to do if, yeah, so let's just make sure that we have all of that. We're going to break that. Yes, so we do like else. So this is a section where we'll do the break, right? So break the loop. So we just put the break. So we realize that we're just coding according to the algorithm that we outlined here. And this is where I wanted to really get. So we'll see how this works. So, and I'm starting with an easy question, so it's much easier. So check if the current element in the input array is not in the output array. Now, is it contains or index of, because for character, for norms, because the idea would be norms. This is not a character, this is not a string, so I cannot do character at. Or index of, sorry. Cannot do index of. Let me see. Can I IntelliJ? Yeah, I want to check my IT. I don't want to Google. I don't want to Google. Um, so just a bit. So let's see. I just want to try to. So int, so like output equal to new int, like 5 there. Yeah, that so previous initialization works. And then I want to do output dot index of. There are functions here. I want to do string dot match. You can also do distinct. String dot distinct, blah blah blah. Yeah, we can use the function, but so it does not have. Oh, that's interesting. You know what? Um, Actually, since it does not have, I think this check, the check, where is it? We did a check somewhere here. This we'll do it here, right? So what we want to do instead of using this is that, well, yeah, because I thought like this is going to have like a function to like find the index, like when you have a characters, you have like index of and stuff like that, or the contains, but this does not have that. So we might as well just eliminate this. So let me comment this out for now. And what I want to do is maintain norms, okay? And remember, we don't need to. However, what I want to do now is actually initialize count, output, there's a count, is equal to 0, right, for now. And yeah, so the initial algorithm is not really that good because of this wrongful, the idea we had here. And so we're going to change it on the fly while coding. And what I want to do is initialize count, and we are going to check, we're still going to do the check, but rather than checking if it exists, we're going to check that while I is equals to 0, so let's see, if I, or you know what, since the first element, like we have empty string, we'll assume that the length, norms.length, yeah, is always 1. Okay, that's good. So we can just increment this. We can also, so according to, for this problem, norms is always 1, right? So there's always something contains norms. So we can just increment 1 and then start I at 1 here. Okay. So I is going to start in the next element, which is this one. And so if I is just 1, then it's going to be 1. It's not going to be less than. It's going to skip that here. That works. And so what we want to do is that we want to make sure that we check if norms I, is equal to norms I minus 1, because one check it against the previous. As long as norms I minus 1, okay, so not equal to, as long as it's not equal to norms I minus 1, we also want to have some kind of a variable here called int next element. Just put like next, and we're going to initialize it to 1, right? So if norms I is not equal to norms I minus 1, which means that if this element here is not equal to this element, right? So whatever it is, we want to, is it norms I minus 1? Oh no. Oh, okay. It's not going to be norms I minus 1, and we're not going to go norms I. It's going to be next minus 1. So if next is not equal to, so I is incrementing, but the next or last element, last. So the last element, or basically the tail, whatever, like we are used to tail, yeah. So we are saving the last element that is distinct, right? So the tail is also 1. So the tail is 0. Yeah, sorry. So we want to say if tail, norms tail is not equal to norms, is not equal to norms I, right? So we want to always measure the last element is not equal to I. Then we want to run all of this. Else, and also else want to break, but that else break only takes place if we run this other check here, and we want to check if norms I is not equal to norms of len minus 1, right? So that's the last element. So this is norms of len minus 1. It's like how it has like a different color here. Not exactly sure why. Anyway. Oh, okay. I'm putting it as a function. That's why it has like a different color. So norms of len minus 1. So this is the check. So I'm checking if the current element, which is norms of I, is not the same as the last element of the array. And so this first check, we're checking if the current element is not the same as the last distinct, last seen distinct element. Okay, so this tail is always going to be the last seen distinct element, right? So it's basically we just put tail there, right? So we are checking if the current element is not the same as the last seen distinct element, or if the element is not the same as the last element. So if the current element is the same as the last seen distinct element, it's going to also check if the current element is the same as the last element. If it is the same, then it's also going to skip. If it is not the same, oh, this is going to fail. Yeah. So you see norms tail is not equals to norms I. This is going to fail, but it's going to take this one and compare it to this one. So is it, if it is the same, so I think it is the same. let's see how this one goes. So it's going to take this one and says, does the current element the same as the last same distinct element? The current element is 1 here, which is 0. Does it, is it the same? Yes. However, is the current element also, is it the same? Yes. So this is going to fail. Is the current element the same? So it's asking if it is not the same. Yes. If it is not the same, this will pass. So it is, what am I talking about? Oh, for it to enter this loop, sorry. Okay, let's start back. If the current element I is the same, it's going to fail, right? Because we're asking if it is not the same, so it has to be a different value. And we're also asking if the current element I is equal to 4, equal to the last element. For it to be able to enter here, it has to be equal to the last element. Okay. So for example, when we get here and this is the last element, we're asked, is this current element the same as this? No. No. So it's going to enter. It's not going to care to check about this one. Even if this one fails, yes. So let's say the one under 4 here, this one is going to fail, but this one passes, and we're using an OR, so it's going to enter. However, when it comes here, and it records this one as now the last distinct element, it's going to check the next element. Is the current element is the current element the same as the last element, which is not the same as the last element, which is yes. And it's also going to ask, does the current element, which is 4, the same as the last element, which is 4? Yes. So it's going to pass, but it's not supposed to pass here. So this is supposed to be not the same. But then you have an issue here, the first one, where this is true. You see the issue there? Yes. So this check can we put like this check? So basically I just want to like put, if so I want it to still enter. I want it to enter, but on the second time it should fail, even though it's still the same, right? So the last distinct element, so the current element, oh, so actually we're going to check if the last distinct element fail. So we've already checked the current element, right? If the last distinct element fail, it's not equals to null, right? It's not equals to that. So let's check that. So we're checking, does 0 equals to that? Yes, so it's going to skip it. Is 1 equals to 0? No, so it's going to approve it, and it's going to ask, is 1 equals to 1? So it's going to, so this works until it gets to 4, where at 4 the tail is 3, right? So it's going to ask for the first time, is 4 equals to 3, which is no, so it's going to pass. And for the second time, it's going to ask, is 4 equals to 3? Is 4 equals to 4? Is yes. However, it's going to also ask, is 4 not equal to, because the tail now is now 4, and the norms dot minus length norms length minus 1, which is 4, assuming that it's under 4 here. So we are taking this scenario, so that I'm talking like that. Seems like, so this is the scenario, and we're assuming that there is something like a 4, something like that, right? So that's what we're assuming. So it's going to get the first time, and this particular, so this will be tail, this will be the current element. So it's going to check, is tail equals to the current element, which is 4. So it's going to now increment and set tail somewhere in this, set tail to the new 4, right? And it's now going to ask, is tail equals to the current element? Now this is a current element, is and tail is 4. Is 4 equals to 4? Yes. Now tail is also still 4. And is it also equals to the last element, which is yes? So it's simply going to skip it, because it must not be equal to the last element. I hope that makes sense. Yeah. So that's what we wanted to do there, and I think if the current, if the last, if the tail, if the last distinct element, the last scene is not the same, so we're checking if the last scene distinct element is not the same as the last element of the array, right? So we want to ask again if true. So we're asking if this is true, we want to do something. We want to move to the next element, right? But now we want to increment our counter. Okay, so we want to increment our counter, add 1 to our counter, which is going to be counter plus plus, right? No, not count plus plus. So that's what we want to do, and we want to now take that element and set it wherever we find the element. We want to take it and set it to, you understand? We want to set the next distinct element. So we want to do norms, right? Norms of tail plus 1 should be equal to norms. Norms of I, right? That's what we want to do. Remember, we don't care about the remaining elements. We just care about the elements we return, the first elements we return while the length of this count, right? For the length of this count. So we increment count, or however you want to do it. You can basically normally do something like this. Normally, just for convention's sake, you set the element of tail plus 1 to that, and then you want to set tail. Tail should be equal to tail. You also want to increment tail, right? Do we even need, because tail starts at 0. Yeah. Or we can use count. We can just use count to determine tail and remove the, because it's just a -1 here, and its count is always going to be 1 ahead of tail, right? So we can just use count. We can use count. So tail plus 1 is equals to count. So we can just use count here, equals to norms, and count plus plus. So if count plus 1, so we'll just count and then count plus plus, right? And so this becomes count minus 1. What am I doing here? Tail, the last distinct element. Okay, yeah. -1. So, which is -1. Okay. Yep. So this becomes not useful anymore, and we don't need to set it as, we can just do count -1. So it's going to be count -1, just for easy sake. And so here we have eliminated one variable. Initialize input, initialize output, initialize count. So move to the next element. We have count plus plus. And then we can iterate. We can now do this, right? We can do while norms. So remember, count is now next element, and the last distinct element is count minus 1. Why count minus 1? Because we already set the last distinct element. So why count minus 1 is equals to norms of I, right? We want to I plus plus. So we want to just move to the next element. And that's what this does here. Yeah. So say else keep calling element. Yeah, so this prevents this from ever hitting unless this, because why it gets here is going to iterate until it finds a distinct element, right? And then comes out of there, and then just I think because we're using a for loop here, we might have an issue. I don't know, I think we might have an issue with the incrementation here. While loop gives us better control because this increments after the entire section, after the entire thing is done. However, if we increment here, it's still going to increment. I think we're going to have an issue here. And it's probably going to make sense to use a while loop. But anyway, I think this is done well. Up to this point, they'll break the loop, assign norms to the output. But since we already have norms, so it doesn't matter, we just return count, right? We just return count. So just like return count. Let's check that out. Yeah. Oh, we're breaking on the first one. That's interesting. I think this problem is that for the small, it's going to work, but that's interesting. Output 1 1, norms 1 1 2, output 1 1, output 2 1, which is not correct. And let's see, it gets 1, so it's already assigning 1. Count is 1, and 1 is going to get 1. Is 1, is count minus 1, which is 1, not equals to 1. I'm sorry, that is not correct. It's equals to 1, is 1 1, right? So that equals to 1, or norms count minus 1 is there, and the last is not equal to 2. But this one is supposed to work. So we have 1. So count is 1. Int I equals to 1. I less than length. I plus plus 0 1 2 3. Let's system that out here. I want to put norms I, and I also want to do, except I'm not assigning norms count, norms, so I'll put do something like point element at I, right? The same thing. Like count, say last distinct what's the problem? I mean, that's supposed to work flawlessly. It only iterates one time. And I'm not sure why it's doing 1 2. Yeah, it does 2 norms I. What is norms I? Norms I is 1. So I'm guessing that this passes somehow. Okay. This is weird. So it takes output 0 0 1 2 3. That's interesting. that should not have worked. So I don't know what's happening. Yeah, I think there is something here, but this is not supposed to run, at least for the first test case. It's not supposed to run. The second test case, however, probably, but the first test case, this is not supposed to run. Right. So let's do a quick change of while. Let's do a quick while loop. So it will be while int, so while I, so we're just going to define int I equals to count. Just like define it to count here. So yi is less than length. We want to iterate I plus plus, so yi. Just want to do I plus plus. Oh, actually, so we want, it's going to come out from here. So it comes and says element at last distinct at 2 is 1. So what's the error? Next 3 out of bound. It said it doesn't check. Oh, and I is left hand. Oh, come on. Am I? What? I mean, is there something wrong with? Am I spelling the length wrong or something? I mean, length is 3, right? And I'm checking if I is less than length. Oh, we are supposed to increment I. Sorry, I plus plus. Before the check. Okay, this is now getting out of hand. So I'm checking if nums I, so the distinct here, last distinct is 1. At 2, element at 2 is 2. And last distinct is at 2 is 1. So I'm checking last distinct. Oh. But I have incremented I is now 3. I is now 3. I is now 3. I'm not exactly sure why, because I've incremented I here, so I've set 2, so we should have like a 1, 2, but I should be 3, right? I should be 3, and so see, is norms 1 equals to norms I, so there is no I3. So we do this length first. We do, if I check the length first, check the length first. I think that's the issue here. Yeah. Check the length first. Okay. 112. Output is 112. I don't know about this. So if element at, so I like this. I like this. Except I don't feel like it's touching anything there. So let's get all of this and put it inside the function. Yeah. So norms I, norms I count. So yeah. So let's check that out and see if indeed it is actually outputting any of this. Yeah, it is. It is outputting it. And it's showing that we are only running this. We are running this twice. So that is weird. That is weird. If norms count, all we care about is I then. So we're checking if norms count. So at this level, the element at I is 1, and the last distinct, what am I doing? Distinct, excuse me. The last distinct at 1 is 1. Okay. And we're checking if the last distinct, which is norms count minus 1, is not equal to norms I, which it is equal to norms I. So this is supposed to fail, right? And then we're also checking if norms last distinct, which is 1, is not equal to, oh, which is 2. So that works. But if we do equal to here, okay, that's basically my check that I wanted to check. So if I remove this should work, hopefully. Yeah, but it takes so much longer. That's the problem. It takes so much because it has to go through the entire case. I wanted to do something that stops if you have like repeated values and makes it more efficient, right? You see that takes it really behind, really behind. Okay, and it's a solution, and I just feel like it will be more efficient if we can, just we can put this. can put this in another if, just within the cell, something like that. If norms of count minus 1 is not equals to norms of count. We want to break here. Yeah. So let's try that. Does it do anything to the... Oh, sorry. Let's just make sure that that works locally before. Yeah. Does it do anything? Oh, it took longer. That's interesting. Okay, that is a solution, but I'm not happy with this solution because apparently it takes so much time, usually for longer values and stuff, and that's because of the two while loops. Yeah, right. It doesn't matter. I don't think it matters where you put this. Because I'm thinking that we should put this up just before the. Sorry. I don't think it matters where this should be placed. I don't think that matters a lot. Either before the solution or after, I think it's still the same thing. Yeah, does not matter. Um, okay. Count I equals 1, length is length. Um, or is it like the print? Is it the print that's the issue here? I don't know why, because this solution seems like it's supposed to be. Yeah, there you go. It's a print. Come on. I was wondering, like, it's a good solution, a really solid solution. At least it shouldn't be that bad. It's a print. The print was killing me. Okay, the print. Is there something we can do to optimize this? Um, the read and write. If we change, if we use add and length, let's see something. I want to check something. Yeah, if we use. Normally, I feel like it should be easier if we have like that, and it should not be. Yeah, it's still the same thing. Um, so we calculate length, and we have count and I. I'm not exactly sure what is the most efficient solution here because this seems pretty straightforward and simple, right? that this our solution should be at least for me, it should be like the most optimized solution, and it's running at 1 second, which is good. Then there is someone that is running at 0 seconds. At least I don't know what they do that we are not doing, right? What are they doing that we are not doing? It's what are they doing that we are not doing? Sorry, so much noise. I don't know, because this seems rather straightforward. Let's optimize this. Just some simple writing. Count plus plus I plus plus norms equals count plus there's that assignment there. I think this is the most expensive apart from the loop and this loop, which is necessary. Now let's see. You're like let's put int till last equal to count. Yeah. And let's see, it should be complete this equal to, will that make a difference? I doubt that will make a difference because we do that computation there, and I think that computation takes a bit more time. So if I think if we do oh no, I'm just trying. So you could have ended the video long ago, so don't stress too much. I'm just trying to see if there's a way one can make this faster. Maybe reduce something. Is there any change? Nope, no changes. Nope, no changes. Yeah. Anyway, that's the idea. So let's take a look at what they do here for them. If norms.length is equal to 0, return 0. That's a given. I mean, is that the thing that makes it? This is the code. This is the code that makes it a bit different. So if I, and I say initialize k equals to 1 as usual, and then I equals to 1, yes. And it says if I is less than norms.length, I plus plus therefore iterate. If norms.I is not equals to norms I minus 1, and I plus plus, right? Okay, plus plus, okay. Are you sure? I mean, it's the same thing. It's literally the same thing, except I am hoping that the code, anyway, or at least this line of code be the one that makes things different. Then, nope, not it, not it. So what's the difference between, I know my one's a bit cumbersome, but it's the same idea. Only I have to stop, so maybe it's just the if functions that I keep checking, or what? It's the if functions. Is it the if function? If that's the case, then we might as well just iterate. You can just put that. Is it the if function? It's the same idea. It's exactly the same idea. Same thing, right? So while, so it's, you don't just a while loop, yeah, same thing, same idea. Same if for loop, and they will check an if, and what happens is nums k is equals to nums I. Yeah, that's exactly what we do, and then we do k plus plus. Hold on. Yeah, same thing, right? Just same thing. Except then this station here is expensive because this is what they did, right? This is what they did. Same thing, I minus 1, nums k equals to I, nums count equals to I, count plus plus, and we return k, which is return count, int k equals to I, int I equals to k. You know what, I think, let's see, replace the length with this, replace the length with this, remove this. Only I tried to do something different, and that is basically what I did, because the idea is basically the same. It just keeps I mean, I don't see the difference between my code and their code at this point in time. This is the same thing. Although they use a for loop, I use a while loop. I mean, which one is much expensive? I'm incrementing the loop here, so come on. You can still change it to a for loop. It's still the same idea. Not exactly sure why theirs is better at 0 milliseconds and mine is just at 1 millisecond. Right? Is it a for loop? Is it like the for I? Where is it? There we go. How's that length? And tell me that that was my problem before. Okay, so at this point in time, yeah, it's official. I have no idea because the count here is the same as k, right? The computation is the same, everything is literally the same, just literally the same, because I think we increment k plus plus here, yeah, that's the same thing. So why is it that theirs runs faster than mine, right? Same thing, even the last situation that I had, mine is supposed to even be faster because theirs have to, you see, these have, if you have that situation you had external, that long for, if it goes to infinity, theirs have to compute all of that, you have to run the loop continuously, and long enough is going to take some kind of memory. Mine, on the other hand, did not have to run that loop, at least at the ending of it, so mine was even better. You have this, you have int k, same thing, is int count, and then the for loop one, and then check, and I mean, come on, in what world is their own faster than mine? even there's, let me copy their solution a bit, or maybe it's my comments, because I am shocked. I am quite shocked that that solution is supposed to get like 100% or something. There we go. So confirmed. There's, I don't know, maybe they ran theirs on a faster machine or their internet connection was faster, but that's the same solution and it is giving me the same person. So our first solution was quite optimized to my understanding. So we are just going to leave it as it was, right? For me, that made sense. Um, yeah. Yes, so for me, this made sense. So we're going to leave it as that. I just wanted to confirm, okay? Um, so yeah, I think there is some kind of a computational issue. Sometimes maybe some people will run faster, some will not run faster, but I think my solution basically even saves the day. It's better than that, right? Because it tackles that edge case where you have repeating numbers ending and it just goes to infinity. Theirs have to run through every number and keep skipping the loop, keep skipping, but it will stay in the loop, right? But mine doesn't have to stay in the loop. It just has to, you know, find that and ask if it is the same and breaks, right? So that's the idea. This is great. This is fantastic. If you like this video and understand the approach and what I started doing here, extracting the algorithm without implementation, before even venturing into writing a single line of code, then I mean, give this video a thumbs up. Comment your approach. Comment what you understood about it, and see you in the next video. Like, share, and subscribe. Connect with me on my social medias for Instagram, Gane Emmanuel, Facebook, Gane Emmanuel, LinkedIn, Gane Emmanuel, GitHub, Gane Emmanuel. So I'm Emmanuel, so just connect with me. Have a nice day. See you in the next video.